Module 1, Pictorial Sketching, Architectural Drawing, Sectional Views, and Surface Standards. Introduction to Module 1. Welcome to Module 1 of Engineering Graphics 2. This module builds upon the fundamentals covered in the first part of the course. It takes you deeper into advanced techniques of technical drawing used in real-world engineering and architectural practice. In this module, we will cover freehand sketching, architectural drawing, sectional and auxiliary views, the development and intersection of surfaces, and begin our exploration into tolerancing and surface finishes. Let's begin with pictorial and freehand sketching. Lecture 1, Pictorial and Freehand Sketching. In engineering, pictorial sketching refers to the representation of three-dimensional objects on two-dimensional media, such as paper or a screen. This helps engineers communicate ideas quickly and visually without using precise instruments. Freehand sketching is essential for engineers and designers. Though it lacks the precision of CAD or drafting tools, it plays a key role in the early stages of design. Freehand sketches are often used to explore design options, communicate ideas during meetings, or document a concept in the field. There are three main types of pictorial sketches. Isometric sketches, which show a three-dimensional object where all three axes appear equally foreshortened. Oblique sketches, where one face of the object is shown true to shape, while the third dimension recedes at an angle. Perspective sketches, which mimic the way objects appear to the eye, with convergence toward vanishing points. To produce effective sketches, practice basic geometric shapes, maintain correct proportions, and understand light and shadow to add depth. Lecture 2, Conventional Drawing Practices. Conventional practices in technical drawing refer to standardized ways of representing objects and features. These conventions ensure that drawings are easily understood across industries and regions. Some key conventions include using standard line types and thicknesses for outlines, hidden features, and center lines. Indicating symmetry, part sectioning, and machining with accepted hatching and notations. Representing threads, bolts, fasteners, and welds according to mechanical drawing standards. Following these conventions helps maintain consistency, which is critical when multiple people work on or interpret a design. Lecture 3, Architectural Drawing Basics. Architectural drawing is a specialized area of engineering graphics. It focuses on the visual representation of buildings and structures. Typical architectural drawings include site plans, which show the layout of buildings within a plot of land. Floor plans, which are top-down views of building interiors. Elevations, which show vertical views of building sites. Sections, which are slices through the building to reveal interior construction. Symbols are widely used in architectural drawings to represent doors, windows, electrical outlets, plumbing, and materials. Understanding these symbols and their standardized meanings is essential for interpreting and creating building drawings. Architectural drawings also use scales extensively. Since buildings are large, drawings are scaled down using common architectural scales like 1:50 or 1:100. Lecture 4, Auxiliary and Sectional Views. Engineering objects are often too complex to understand from a single view. This is where auxiliary and sectional views become vital. An auxiliary view is an additional view projected from one of the principal views to show inclined or oblique surfaces more accurately. It helps present the true shape and size of slanted surfaces that appear distorted in standard orthographic views. Sectional views are used to show the interior of a part by slicing through it. These views remove part of the object's exterior to reveal features that are otherwise hidden. Types of sectional views include full section, where the object is cut completely along a plane. Half section, which cuts away only half of the object, useful for symmetrical parts. Offset section, where the cutting plane is bent to pass through features not in a straight line. Broken out section, which reveals a small portion of the interior without a full cut. Proper hatching, or patterning, is applied to show the cut surfaces in section views, indicating the type of material or feature. Lecture 5, development and intersections of surfaces. In engineering fabrication, especially in sheet metal work, developments are vital. A development is a flat layout of a three-dimensional object. It shows how a shape can be cut from a sheet and folded into the final 3D form. Developments are used in manufacturing docks, cones, boxes, and pipes. Commonly developed surfaces include cylinders, cones, prisms, and pyramids. The intersection of surfaces arises when two solids meet or penetrate each other. Understanding the lines and curves formed at these intersections is crucial in designing fittings, piping networks, and joints. Drawing accurate intersections involves projecting elements of one shape onto the other and finding common edges. The process can be complex and requires strong spatial visualization. Lecture 6: Introduction to Limits, Fits, and Tolerances. No physical part can be manufactured to an exact theoretical dimension. This brings us to limits, fits, and tolerances. Limit dimensions define the maximum and minimum acceptable sizes of a part. Fit describes how tightly or loosely mating parts assemble together. There are three categories: clearance fit, interference fit, and transition fit. Tolerance is the permissible variation in a part's dimension. Engineering drawings specify tolerances to ensure functionality while allowing economical manufacturing. The choice of fit and tolerance depends on the application, material, and desired performance. Lecture 7: Surface Roughness and Engineering Finishes. Another crucial aspect of part performance is surface texture. Surface roughness refers to the fine irregularities on a machined surface. It affects friction, lubrication, and wear. Drawings may include surface finish symbols to indicate the required smoothness level. These symbols guide the machinist on the type of finishing process to be used, such as grinding or polishing. Understanding how surface finish affects part functionality, especially in rotating machinery and mating surfaces, is important for engineers. Module 1 Summary. In this module, we have explored several advanced concepts in engineering graphics. The importance and techniques of pictorial and freehand sketching. Standard conventions that bring clarity and consistency to drawings. Basics of architectural drawings and their components. Auxiliary and sectional views for understanding complex parts. How to represent developments and intersections in design. An introduction to limits, fits, tolerances, and surface finishes. Each of these areas plays a vital role in communicating design intent accurately and effectively, especially in collaborative engineering environments.